And here's the full proof of the chord bisector theorem. Converse of chord bisector theorem. In a circle, if a chord is the perpendicular bisector of another chord, then the first chord is a diameter. Given that XE and XA are congruent, and CS is perpendicular to AE, prove that CS is a diameter of circle O. In a circle, if one chord is a perpendicular bisector of another chord, then the first chord is the diameter. This proof is very much like that of the original theorem, of which this is the converse. Construct triangle OAX and triangle OEX, and by proving them congruent, you show that OA and OE are radii, which means that chord CS passes through the center and is the diameter. Here's an example. In circle O, BD is the diameter, and BD is perpendicular to CE. Find the measure of arc CD, the measure of arc DE, and the measure of arc CE. Alright, so because this is a bisector here, we know that this arc is congruent to this arc here, so we can set them equal to each other. 9x equals 80 minus x. So we'll add 1x to both sides. That gives us 10x equals 80. Divide both sides by 10, and we get x equals 8. So to find the measurements of these arcs, we just plug 8 in wherever we see x. So 9 times 8 equals 72 degrees. Here we have 80 minus 8 equals 72 degrees. And CE, we have 72 plus 72, which is 144 degrees total. Here's an example. Given circle C, QR equals ST equals 16. So this length here is 16. This length here is also 16. We're going to find CU. All right, so let's prove a couple triangles congruent, and that will help us here. So if we draw these radii from here to here and from there to there, we know that all of these are congruent to each other since these are all radii of the circle, so they're all congruent. We also know that they each have a right triangle in them. So right now we're trying to prove that all 4 of these triangles are congruent to each other. So because these are right triangles, hypotenuse leg is going to help us here. So we have to prove that this leg here is congruent on all of the triangles. And that's going to be 8 because the chord bisector theorem states that if a radius of a circle is perpendicular to a chord, then the radius bisects the chord. So we know that that's 8 and 8. So we know that this U point here is the midpoint. Same down here. So we know that this part is 8 and this part is 8. V is the midpoint. So due to hypotenuse leg, we know that these triangles are all congruent to one another. And because corresponding parts of congruent triangles are congruent, we know that this side here is congruent to this side here. Therefore, we can set them equal to each other. 2x equals 5x minus 9. So we will, let's subtract 2x from both sides and add 9 to both sides. So that becomes 9 equals 3x. Therefore, x equals 3. So we're trying to find CU, and CU is 2x. So 2 times 3 equals 6.